And now we come to digital twins and the components of a digital twin. Full disclosure, sometimes I try to avoid using the phrase twin because it can mean so many different things to different people. I try to focus on what problem are you trying to solve with a twin? What's the specific use case? But for discussion purposes, at Lockheed Martin, we've settled on three primary components for twins. Number one would be a virtual product or process that exists in a virtual environment. Number two is a physical product or process that exists or will exist, important caveat, in a physical environment. And third is the data that connects the two, connecting the virtual and the physical, also incorporating advanced analytics to make those end users able to make those intelligent predictions and decisions. So we all know that having a validated model is great. It provides you data of an object at a specific moment, but the real power of twins is that they provide you an accurate description of an object that changes over time. And as more and more data becomes available, your models, your simulations, your predictions become more accurate, they become more trustworthy, and that's going to greatly increase your customers' confidence in the value of using and continuing to fund digital twins. So as promised, I want to share with you a few Lockheed Martin digital twin use cases. And I want to emphasize also, we're focused on having visibility of a product or a process across all the different stages of a life cycle, ideally from cradle to grave. We don't want to have disconnected or siloed twins. That's the problem we're trying to solve. We want them ideally all connected to authoritative source of truth data on a digital thread as much as possible. And to help us envision that, we've come up with 7 different views, which are listed across the top of the slide. They're as designed, as built, and as maintained. So the focus here is the configuration of the pedigree of the product. Mission performance focuses on the operational performance of a product and how different configurations meet or ideally maybe exceed customer requirements and product design goals. Facility and process, so an example of that would be a simulation of a manufacturing facility to include smart machines, processes, product flow through a facility to optimize your throughput, ideally all before you cut metal and start production. Supply chain, focus on demand forecasting of parts, availability of parts, to aid manufacturing and long-term product support, and sustainment. So the focus here is on product usage data, using twins to predict how a product will perform, and that may also include prognostics to inform condition-based maintenance. Note that some twins prioritize data visibility for only one of these views. Some twins cover multiple views, which we'll see here on the next slide. So I'll talk to you a little bit about the Argus Hardware Digital Twin. It provides users visibility into engineering data in the as-built, the as-maintained config, as well as the supply chain and sustainment views per the highlighted views up top here in yellow. Argus stands for Analytic Recursive Generation Unified System. Step 1, Argus is focused on first laying the groundwork for a functioning digital thread, synchronizing and aggregating all the known data of a physical asset into one system. Argus provides you a one-stop shop approach to finding what you're looking for by aggregating data into one user interface. We aggregate data from multiple sources of truth, such as a product lifecycle management or PLM tool, and requirements databases. So the benefit of this approach is that users don't have to hunt and search through multiple tools to find what they're looking for. And the result of that is you have one tool, it's better, it's quicker access, you can get to source of truth data in one tool. It also is a tremendous cost savings for not having to pay for multiple software licenses or training users on how to use different tools. So also note that changes to the engineering baseline would occur outside of Argus. We still observe engineering change processes and configuration management. If you look down the lower right of the slide, Argus has 5 views across the different tabs of its user interface, and that allows you to interact with the digital twin data at different life cycle stages. So we have engineering, we have a sustainment view, we have a supply support view, we have a state profile view, which enables you to do high fidelity modeling and simulation, predictions and wargaming, and a simulation view, which includes augmented reality and virtual reality AR, VR experiences. So also I wanted to mention that Argus is a product agnostic digital twin. The example you see here is a missile, but any product could use Argus for digital thread, digital twin capabilities. So the second example I wanted to share with you is primarily focused on facilities. The company has dozens of industrial Internet of Things, or IIoT technologies that are enabling digital twins, from AR and VR, training, remote assistance, to drones, vibration monitoring, RFID and Bluetooth for tracking products through, for example, a manufacturing facility or a repair depot. We have predictive maintenance. We have smart buildings that I'll talk about in a minute that can detect and diagnose failures, condition-based maintenance, and also 3D scanning of objects like platforms or buildings. And the last example I want to share with you focuses on both facility and process. The goal was to embed fault detection and diagnostics, or FDD, capabilities into our facilities. I'm not going to read the entire chart to you, but I think you'll see these smart buildings have already saved the company a lot of money. There's over 4,000 connected assets, 30,000 connected sensors with 3.6 billion, give or take, data transactions per day. So using this FDD really helps us decrease facility spending and results in increased asset availability, reliability, labor efficiency, employee comfort, better predictive maintenance, increased knowledge sharing, and improved data standardization overall, which is extremely critical, as you can imagine, with digital threads and digital twins. I think this is another really good example of how Lockheed Martin is using digital twins internally to make us more efficient and cost effective.